I'm Anil Kumar. Welcome to my series on providing solutions to international test papers. Here is one from Cambridge International. It is Level 3 Advanced Mathematics, June 2018 test, question number 12. Prove that 1 minus cos 2 theta is equal to tan theta sine 2 theta, where theta is not equal to 2n plus 1 pi over 2 and belongs to set of integers. So this value will make tan theta as undefined, so that is the restriction. Part B is, hence solve for x greater than minus pi by 2 less than pi by 2 the equation secant square x minus 5 times 1 minus cos 2x equals to 3 tan square x sine 2x. Correct. So that is the question for you. You can always pause the video, answer the question, and then look into my solution. You're also required to give any non-exact answers to 3 decimal places, right, where appropriate. Okay. So to prove this identity, few formulas you should remember, which is we have sine 2 theta here. So a formula relating sine 2 theta is 2 sine theta cos theta, right? Cos 2 theta formula. So cos 2 theta in terms of sine theta can be written as 1 minus 2 sine square theta. Correct? So we are going to use these two formulas to prove this identity. Okay. So let me just show it here itself. Less space we'll use for part B. Now cos 2 theta is 1 minus 2 sine square theta. So we'll start with the left side. Which is 1 minus cos 2 theta. I'll write this as 1 minus. Instead of cos 2 theta, I'm writing 1 minus 2 sine square theta. Correct? So that's my left side. So when you open 1 minus 1, that becomes 0. And what we get here is 2 sine square theta, right? So what we get here is equal to 2 sine square theta. Clear? Now, what we really need is tan theta sine 2 theta, right? To get sine theta, to get tan theta, we need to have cos theta in the denominator. So what I can do here is we can multiply this by cos theta and also divide by cos theta, correct? So once you do that, what you get in the numerator is sine theta, so we'll just rearrange the terms, times 2 sine theta cos theta divided by cos theta, I'm writing here, mainly because I need tan theta, right? So sine over cos is tan, perfect, and 2 sine theta cos theta is sine 2 theta, correct? Clear? Which is same as the right side. So you could go any way to prove this, and that is how we are going to show it. So I hope that is clear, right? Now, part 2 is we are given an equation secant square x minus 5 times 1 minus cos 2x is 3 tan square x sine 2x. Now, we already know that 1 minus cos 2x is tan theta sine 2 theta, right? So we can rearrange this. And we can write everything in terms of tan. Secant square x, secant can be written as cosine, right? And 1 minus cos 2x will write as tan theta sine 2 theta, correct? So let's do this proof right here. So first step, we'll do secant square x. What we are going to use here is these steps. 1 plus tan square x equals to secant square x, correct? So that is the property which we are going to use here. So instead of secant square x, I'm writing 1 plus tan square x. We already have minus 5 here. And this expression is basically equal to sine x, tan x, sine 2x, right? So we'll write this as tan x sine 2x. Clear? The idea is we have similar terms on the other side, which is equal to, here we have 3 tan square x sine 2x. Does make sense to you, right? So that is how we're going to do it. Now, let's simplify this. So what we get here is tan square x minus 4 times tan x sine 2x. And we can bring this to the left side. So we get minus 3 tan square x sine 2x equals to 0. So basically, what we have here is that we can take the tan x sine 2x common, right? So we can take tan x sine 2x common. So we get tan x sine 2x. Within bracket from here, we get tan square x minus 4, right? And from this side, because we took tan x sine 2x common, we get 3 tan x, right? So what we get here is 3 tan x minus 3 tan x equals to 0. Correct? So we get a quadratic equation here, but here we have two factors. We can actually factor this also. So these factors will give us solution. Let's rewrite. So we have tan x sine 2x. Now that is a quadratic equation, which let me rewrite. Tan square x minus 3 tan x minus 4 equals to 0. We need product of minus 4 and sum of minus 3. So that means 4 times 1, right? So we could factor this. 4 times 1 can work for us. So we can write this as tan x sine 2x. So 4 times 1, 4 is negative. So we have tan x minus 4 times tan x plus 1 equals to 0. Clear? So we get 4 factors. Now each one of these factors will give us the solution. So tan x equals to 0. And remember, we are working in this domain, which is minus pi by 2 to plus pi by 2. For sine 2x, if I write 2x here, in that case the domain will become, if it is 2x, in that case it will be from minus pi to plus pi. So that's important to remember, since sine 2x equals to 0 will give us values within this, but pi and minus pi are not included. This is very important to understand. Is that clear to you, right? So for tan x equals to 0 and sine 2x equals to 0, we get the same answers. For these, we get, if I want to write sine 2x equals to 0, so that basically means x is equal to 0 degrees, correct? So that is one way. Second is, we want this factor to be 0, so we have tan x equals to, equals to 4, and we have tan x equals to minus 1, right? So x value is tan inverse of 4, and here we have x value as tan inverse of minus 1. Now within this time period, let's look into this slightly more details. We need positive value. So basically, we are working for x within this domain, correct? From minus pi by 2 to plus pi by 2. When I say it is positive 4, that means we are looking in this quadrant, correct? And when we say minus 1, we are looking into this quadrant. This is for minus 1, correct? So that minus 1 value will be minus pi by 4. So this value is x is equals to minus pi by 4, correct? And for this, I need to use calculator. So we do tan inverse of, so let's convert this to radians first. So we'll change the mode to radians, which is 4. Okay, and now we'll do tan inverse of 4. We get 1.32, right? We have to round this to 3 decimal places. So this gives us x equals to 1.33 decimal places, correct? So 3258, so we'll write 326 radians. Correct? So not 0 degrees, 0 radians. Both are same though, but that is how we're going to do. Perfect. So I hope the steps are absolutely clear. Let me rewrite the answers here. So we get answers as x equals to 0, minus pi by 4, that's the exact value, and 1.326 radians. All are in radians. Correct? So that is how we need to solve this. Excellent question. Question number 12. I hope you understand and appreciate what we have done here. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that would be great. And in case you have any doubts, you feel free to send me an email on the address given here. Thank you and all the best.